In this lesson, we're going to take a look at implicit differentiation. And really, I think the best way to start this is by looking at an implicitly defined function. X squared plus y squared equals 4, say. That's a circle. It's a circle of radius 2, center to the origin. And so I said function, but it's not actually a function. It doesn't pass the vertical line test. And let's say we wanted to know the slope of the tangent line to that circle right there. How can we find that? What would we be able to do in order to find the slope of the tangent line at that point? Well, if we think about the limit, right, as we let x approach this point, we could look here or here. We look at the top or the bottom. And if we focus in on just this piece of the graph, we could rewrite this as a function described in terms of y, where it is a function. We just say y equals 4 minus x squared, and then we take the square root of that. And now we are looking at just the top half of that circle, and we can find that derivative. So if we want the derivative of this thing, we just say, okay, well, let's take the derivative with respect to x of both sides. So the derivative of y with respect to x is equal to the derivative of the square root of 4 minus x squared with respect to x. So this gets us derivative of y with respect to x is equal to, and then we chain rule that, right? So we have 1/2 4 minus x squared to the negative half times negative 2x, the derivative of that inside function. And that gets us there. But that's because this was relatively easy to solve for y. And it did limit our function to only looking at the top half of that circle, and we could repeat it for the negative half of that circle. Well, if we're just interested at a point, we can do this implicitly. And when we do this implicitly, instead of solving this equation for y, we just go ahead and let the derivative operate on each term individually. So what I mean is we're going to take the derivative with respect to x of x squared plus y squared equals, if we take the derivative of the left side, we've got to take the derivative of the right side. So the derivative with respect to x of 4. Now that derivative just comes through. The derivative of the sum is the sum of the derivatives. So we have the derivative with respect to x of x squared plus the derivative of y squared with respect to x. And then this equals the derivative of 4. Well, this is 0, right? Derivative of a constant is 0. This we can do. The derivative of x squared with respect to x, this is 2x. Power rule, right? This we're also going to do, power rule. So this is 2y. But then we have dy dx. And the reason we have this dy dx is because we are still considering y to be a function of x, and we are differentiating with respect to x. So just like if we had y equals sine x squared, we would do the derivative of y with respect to x is the derivative of sine x squared with respect to x. And we would see, well, this inside function, the derivative of sine, this is cosine x squared times the derivative with respect to x of this inside function, x squared. Well, power rule that, and that would be cosine x times 2x. And you could even argue that we need to take the derivative of x, right, the last inner function of that, with respect to x. Well, dx is just 1. The derivative of x is 1, and so that doesn't actually affect anything. But over here, when we do that, we're considering this y as a function of x. So we pulled the power out front, followed the power rule, so 2y times the derivative of that inside function. Well, that's dy dx. We don't know what that is, but that is actually what we're looking for. So we just treat x, y, and dy dx as variables. And so now I have 2x. I'm going to subtract I'm going to subtract the 2x over. So if I subtract 2x from both sides, I get negative 2x equals 2y dy dx. And then I can go ahead and divide both sides by 2y and get dy dx is equal to negative x over y. And you might think to yourself, well, that's very different than the derivative we got over here. But it's not really, okay? 4 minus x squared, right here, this term, okay, that is y squared, because we have y is equal to the square root of 4 minus x squared. And so we have, if we rewrite this, dy dx is equal to 1/2. We have this negative 2x, and then in our denominator, we have 4 minus x squared, so the square root of 4 minus x squared. Well, the square root of 4 minus x squared is y. So dy dx is equal to half of negative x over y. So they are, in fact, in total agreement with each other. Here, we did this implicitly. Here, we made an explicit function in terms of y in terms of x. Implicit differentiation allows us to do this for equations that are a lot more complicated than just a circle. You can't always solve something for y, and even if you can, you might not be able to do it simply. So instead, we do the implicit differentiation. And really, you do the derivative of each term following all the rules you normally would. You just have to remember you're treating y as a function and not as a variable. So when you're differentiating with respect to x and you come across a y, you follow the same rules as you do for differentiation, but then you remember it's a function, so you always have to multiply, you always have to do the chain rule and multiply by dy dx. So let's look at one more example of that real quick. If we want to find dy dx for, say, x squared plus 2xy minus y squared equals 4. Okay? We're going to take the derivative with respect to x of each term. So the derivative with respect to x of x squared plus twice the derivative with respect to x of xy, I just pulled that 2 out front, minus, I'm going to pull out that negative 1, the derivative with respect to x of y squared equals the derivative with respect to x of 4. And then we're just going to go ahead and do this. Well, the derivative of x squared, 2x, plus 2, the derivative of this. This is a product rule. We have an x times y. So the derivative of the first term, x, is 1 times the second, which is y, plus the first, which is x, times the derivative of the second. Well, that is dy dx. We don't know that is a function, so it's dy dx. Minus power rule, so 2y, and then the inside function of y is dy dx. And this is equal to 0, because the derivative of a constant is 0. Now we just have to isolate our dy dx and solve for it, and we can find the derivative. So I have 2x plus 2y plus 2x dy dx minus 2y dy dx equals 0. I'm going to go ahead and add the 2y dy dx and subtract the 2x dy dx. So now I have 2x plus 2y equals 2y dy dx minus 2x dy dx. And then we can factor out this dy dx. We can factor out the 2 as well, but 2x plus y equals 2 dy dx times y minus x. And then we just go ahead and divide both sides by 2 and by y minus x. So then we have x plus y over y minus x is equal to dy dx. So we've solved for the derivative of y with respect to x. And it's still in terms of x and y. So if we're doing this at a point, that's fine. We know our x and y values at a point.